Hey, welcome. So today, we're diving into one of the absolute biggest questions in AI right now. How do you actually get these incredible models out of the lab and working reliably in the real world? It's the puzzle every business is trying to solve, and, well, getting it wrong can be a total disaster. All right, let's get into it.
This right here is the whole ball game. A model can ace every single academic test. It can shoot to the top of all the leaderboards, and then completely, utterly fall flat on its face the second it interacts with a real customer. And you know what? This isn't some rare fluke. It's pretty much the standard experience for so many companies trying to innovate right now.
And the consequences are very, very real. I mean, Air Canada was legally forced to honor a refund policy that its chatbot just made up. New York City had a chatbot for businesses that was caught giving out illegal advice. But these huge public fails, they're really just the tip of the iceberg. That last point on the slide, that shows you the real story. 85% of companies are playing around with generative AI, but almost all of those projects die before they ever see the light of day. And why? It all comes down to this giant gap between the hype and the reality.
And this brings us right to the core of this whole explainer, the production paradox. If these models are supposed to be so brilliant, why are they failing in such public, expensive, and frankly, embarrassing ways? Well, the answer isn't about the model being smart, it's about how we're measuring success in the first place.
The diagnosis for this whole problem is what we call the benchmark to business gap. There is a massive, fundamental disconnect between the kinds of tests AI models take in a lab setting and the messy, complex, high-stakes demands of a real business.
And this slide just lays it out perfectly. On one side, you've got your academic benchmarks. They're great for measuring stuff like general knowledge, how well a model can answer a trivia question. But then look at the other side. What do businesses actually care about? They're worried about totally different things. Is it going to cost a fortune to run? Is it fast enough for my customers? Is it secure? Can I count on it to work the same way every single time? Your typical academic score just doesn't even begin to answer these questions.
Let's just talk about cost for a second, because this is wild. For the exact same level of performance on a business task, one AI could cost 50 times more than another. 50! If you're only looking at a simple accuracy score, you are flying completely blind to this enormous hidden cost that could sink your entire project.
And then you've got reliability. So a model might get something right 60% of the time if you just ask it once. And you might think, okay, that's not terrible. But what happens when you need it to be consistent? What if a customer has to interact with it just 8 times? All of a sudden, the success rate plummets to 25%. For any real-world business process, that's not just bad, that's completely unusable.
So, okay, if the old way of measuring is broken, what do? Well, the solution starts with a completely new way of thinking, a new framework for figuring out what's actually important to measure in the first place.
So let me introduce you to the CLEAR framework. It's built from the ground up for what businesses actually need. Instead of just one simple score, it looks at 5 absolutely critical areas. You've got C for cost, L for latency or speed, E for efficacy, which is just a fancy way of saying, does it actually work? A for assurance, which covers things like safety and security, and finally R for reliability. It's the whole picture, not just a tiny snapshot.
And here it is. Here's the proof that this whole approach actually works. When researchers looked at how well evaluation scores predicted real-world success, the old accuracy-only methods had a pretty weak correlation, just 0.41. But the CLEAR framework? A whopping 0.83. Let me put that another way. Measuring across these different dimensions is literally twice as effective at telling you if an AI is going to succeed or fail when it really counts.
Okay, that's great. We have a much better framework. But you're probably thinking, measuring all of that sounds really slow and really expensive, right? I mean, how can any company possibly check every AI response for cost and safety and reliability, especially when you're dealing with thousands of them? Well, this is where things get really interesting.
The solution has a great name, LLM as a judge. And the idea is as simple as it is powerful. You use one really good AI model to grade the work of another AI. You give it a clear set of rules based on your clear criteria, and it can go through thousands of outputs, evaluating them with the kind of nuance you'd expect from a human expert, but at the incredible speed of a machine. It's the secret sauce that makes all of this practical.
And the best part is, you've got options. You could use a massive proprietary model like GPT-4 as your judge, and it does a great job of agreeing with human evaluators. But, and this is really cool, there are also specialized open source models, like one called Prometheus. Now, what's fascinating here is that Prometheus actually scores a tiny bit higher in its correlation with human judgment. Plus, it's completely open, so you know how it works, and it's way cheaper to run. This means any business can build a top-tier evaluation system without getting locked into a single expensive provider.
So we have the what, the clear framework, and we have the how, AI judges. Let's put it all together into a playbook you can actually use. Here are 4 steps to building an evaluation process that will give you real, actual confidence in your AI systems.
First up, define your use case. What really matters for this specific task? Is it speed? Is it safety? Figure that out and set hard go or no-go limits. Second, use your own data. Test with real questions your customers are asking, including the weird ones, not just generic stuff from the internet. Third, and this one's huge, actively try to break your model. We call this adversarial testing. It's way better for you to find the weak spots than for your users to. And finally, use a hybrid approach. Let AI judges do the heavy lifting at scale, but always keep human experts in the loop for the most important decisions and to make sure your AI judges are staying on track.
And that brings us to our final thought for today. We've just talked about how AI can be used to evaluate other AI with incredible human-level accuracy. This creates an amazing feedback loop. So the big, kind of mind-blowing question I want to leave you with is this. If an AI can reliably figure out what makes a good or bad response, what does that mean for its ability to teach, to refine, and to ultimately improve itself? The era of truly self-evolving AI might be a lot closer than any of us think. Thanks for joining.